おはようございます。今日の朝のフーディニ作業配信を始めていきたいと思います。今日はパーティクルのシミュレーションをやろうと思います。最近ちょっとレッドシフトの使い方に慣れてきてはいるんですが、今回のやろうと思ってた動画もレッドシフトでセットアップしているので、レンダリングまで含めてちょっとやってみようかなと思います。はい、では動画に切り替えます。
And let me know if you also love to organize your setups in like super neat way. And I see that we don't have like 90 degrees angle here, so it just like an OCD or something. But yeah, and in general, if you have any thoughts, recommendations, suggestions, anything, YouTube algorithm really loves your comments, and when you are commenting, it kind of pushes my videos to more viewers. So I would really appreciate if you leave me a comment. All right, so let me show you. First of all, we obviously need a
じゃあフルディに戻ります。今回はちょっとバージョンがわからないんですが、やっぱここのバージョンの部分はいろいろパスとかが出たりとかで結構見せてくれない人がいるんですが、この辺の UI とかを見る限り、おそらく19じゃないかなと思うので、念のためバージョン合わせて、新しい時はバージョン合わせていきます。というわけで、19を使っていこうと思います。大丈夫。最近 GPU の使用率高いんだよな。
source of our strands, and here let me just quickly duplicate our line wave node. I will remove the rotations. It will be easier for you to understand what's going on there. Alright, so what we have here is our tiny little circle here. Yeah, we can remove the normals and divisions here. I link that to my controls node. Number of splines set to 2000, so we have 2000 little points here. If you're not familiar with the controls now, I use it in every of my Houdini setups. So basically I can just write down parameters and it will be just like easier for me to understand where and what was. So here, yeah, number of splines is basically divisions of the circle, and its primitive type set to polygon range.
これインとかフローとかわかんねえな。書いてないんだっけ。これはインとか。型まで書いてないんだっけ。 ントにしとこう。レンジがわからん。これが300。レンジがよくわからんとりあえず12にしとく。で、これでいいか。この辺に置いとこう。
For me to understand where and what was. So here, yeah, number of splines is basically divisions of the circle, and its primitive type is a polygon orientation Z explain, and I scaled it down. So then we drop a sort node, and here I want to sort the points in
ザナンバー。これ最初のから聞
our
き直すか。
tiny little circle here. Yeah, we can remove it. Normals and divisions here, I link that to my controls node, number of splines.
こうか。そんなに割るの？ちょっと待って。
Set to 2000, so we have 2000 little points here. If you're not familiar with the controls null, I use it in every of my Houdini setups. So basically I can just write down parameters and it will be just like easier for me to understand where and what was. So here, yeah, number of splines is basically divisions of the circle, and its primitive type set to polygon, orientation z explain, and I scaled it down. So then we drop a sort node, and here I want to sort the points in a random way. I will explain why we really need to do that a little bit later. Spoiler, it is needed for proper coloring. And then we drop an attribute wrangle. So what we need to do here, one thing is absolutely crucial, that we need to set up our normals pointing outwards. And here I can basically, let me bypass these two.
ノーマルを外に向けて、なんかおかしいな。アトピー。なんでこれ小文字？あれ？こうだな。で、ゼロ。
Nodes, and I can copy to points, or actually maybe, yeah, leave the transform node here. Let's also decrease the number of splines to something like 200 maybe, yeah. When I copy to points, you can see that we have our splines pointing outwards. If I remove this line or comment out this line, this is what happens. So yeah.
ノーマル入ってるよね。 かしいな。ああ、そういうことか。え、あれ、コピーつって逆になった。コピーするジオメトリーでターゲットポイントでしょ。見づらいな、これ。暗くて見えなかっただけかよ。はいはい。
We want our copies to follow the normals, and normals should be pointing outward. Then prim ID, just a custom variable pointing to pt_num because we want to store our IDs of points. Then the p scale is set to 1, and this is to make our center or affected by noise line surfaces or areas. I want them to appear thicker than the rest. And then we are just coloring it to black. So that's it. For the lines itself, have a line, points, again linked to my controls node, and spline resolution is set to 300, so we have 300 points. In this line, here you can see it. Basically, the lower the number of points in the line, the less details you will have in your noise. So you may start with, I don't know, 100 and then go insanely crazy, as we usually do on this channel. So then I dropped a bend node, and bend node basically creates the shape of our sphere. So here you can see the parameters. I kind of like the trial and error here, so I set the
プラスで。いいじゃん。ずっとで。うんうん。そっか。Z に対して。
bend to be minus 17.7, then check to preserve the volume and enable the length scale, and capture is set to capture origin set to z-axis minus 0.1. So this gives me fairly correct sphere in the end. When I attach the bend and attribute wrangle to the copy to points, I have my sphere. Cool looking sphere. So now let's go and create some noise.
ああ、そういうことか。0.1ずらして、空いてる部分だけずらしたってことか。0.1入ってて。なるほど。
And this time we will be using warps. So drop a point warp and I'll explain you what we have here. So we have our turbulent noise, which is, yeah, just
ベロシティに突っ込むかな。
just turbulent noise, and we have signature set 3D noise, noise type. I've set that to sparse convolution node, frequency is 0.533, amplitude is set to 2, roughness to 0.7, attenuation to 1, and turbulence to 6. Then I drop an add node and I feed the position to the one and turbulence to 6. Then I drop an add node and I feed the position to the turbulent noise, and I also feed the position to the add, and that's how we add the noise to the original position. Also, I dropped a divide constant node and I dropped a time, and I attach the time divided by, in my case it's 12, but it also like set to this controls node, and then I plug it into the offset of the turbulent noise, and then I plug that all into position of the out. So let me visualize it. That's our noise. You can play with these skills here and there, but yeah, these are the values that I used. So complete setup for the WOP is super simple, and it looks basically like this. So we have our points that are kind of like noisy and displaced, but we surely need something that will determine which part of the, in this case, sphere will be affected by the noise. And previously we used attribute transfer and it was working great, but now I discovered this node mask from geometry, which seems to me a bit more versatile and easier to use than attribute transfer. So basically what we have here, we get our copy to points and we drop a mask from geometry, and then we drop a, in my case it's a torus, and I have animated many of these parameters, so the animation looks like this. We scale and go up, and then we scale down and we also go up. So basically we scale and go up, and then
でマイナス3だから。
we scale down and we also go up. So basically this is the animation we want. In our mask from geometry, we have a remap. In this case, the radius is set to 1.3. By default, it will give us something like this. So you can see how the mask actually works. I really wanted this gradient to be even more smoother. I added attribute blur, which
違いわかんねえ。このパラメータがな、あるとダメなのか。
blurs the mask attribute. So here you drop an attribute blur, attach the mask to the blur. In the attributes, you specify that you want to blur the attribute called mask. Blurring duration set to 50, pin border points unchecked, influence type proximity. That's it, yeah. And then I attach a color node, and color type is set to rem from attribute set to mask, and range is 0 to 1. So that's how I can visualize and tweak the look of the mask. So now this is one of the most interesting parts, and this function is used in so many cool projects, and I just want to share it with you. And don't be afraid of this little wax. So here we should create two variables, assign values. Our
んここ広げられねえの。で、ランプで切り替えることによって、そう、ポップでノイズかけてんのか。なるほど。
First vector is our first input point position, so it's basically all the points from this one, and the vector pt2 is position of the points here in our noisy, and because the point count is the same between the initial and noisy, we can linearly interpolate between positions of these points. So function lerp is a linear interpolation function, and it needs the first and second position and the scale of interpolation. So the scale of interpolation is basically our mask, and mask has values from 0 to 1. Black parts are 0 and white parts are 1, and that means that if we have our mask, let's say here on the frame 150, it is here in the middle, and here in the middle it's 1, so these parts will be affected by the noise, and these parts here, which are black, which are 0, will not have any sort of noise and will remain from the pt1, which is our state of default sphere. Let me display this attribute wrangle, and you can see that we have this exact interpolation, and as our mask grows and goes up, the interpolation, the lerp function, also works and checks every frame which points should be affected or which points should not. So this is extremely useful function where you want to quickly, let's say, show one part of the mesh being affected by the noise, and then you can just like go back to the normal state or something. Basically, interpolation makes easy to transform or morph between different setups. The only thing is that the point number of first and second geometries should be the same. So after this first attribute wrangle, I've dropped another one, and I'm also using the lerp function, and in this example I am linearly interpolating the p scale from 1 to 3, and again I'm using the mask, so these parts that are noisy will appear thicker.
スケールノイズが高いときにスケールがでかいと。
than the ones that are not affected by noise. So basically that's it, and now we just need to make this looking good and pretty. So let's drop a color, and we can ramp from attribute. Attribute should be prim ID. That's why we specified it here in the attribute wrangle, so prim ID. And remember I told you about the sort. So let's see what happens if I disable that. You can see as we are driving our color from the prim ID, which is ptnum, we basically start from 0 here and we go 0, 1, 2, 3, 4, 5 until in this case 2000. And this is why we need to randomize. So the range
そっとかけないと綺麗にならんじゃうよね。そっとかけるとバラバラになりますと。
range also here it's actually not 2000 but 200, and range is 8 to 200 because I have my spline num or number of splines parameter copied here. Only after color we can resample, and in resampling I set the length to be 0.02 and treat polygons as subdivision curves. It makes the curves a bit smoother so they don't have like these straight edges. And after that they don't have
サブディビジョンカーブはあれか。ノイズした後の方にかけてるのか。
have like these straight edges. And after that there is also an attribute wrangle, and this is one of the coolest parts of this tutorial. So it's very easy, and here I basically explain that. So we multiply the color value by mask attribute. value to achieve a smooth gradient from black, which is our primary color of the sphere, where the mask is 0, till the full color where the mask is 1. So let's say the color is 1, so the spline is red, and we multiply it by mask. So if we multiply it by 1, we get the 1. If we multiply by 0, we get the 0, so the black. So if I display this one, you will see that we have sort of a smooth gradient here. It's difficult to see here, but we basically are done with the setup here, and let me show you how it looks rendered in Redshift. So to render it out, you will obviously how it looks, but we basically are done with the setup.
真ん中が弱いな。これ円が広いのか。
Setup here, and let me show you how it looks rendered in Redshift. So to render it out, you will obviously need
ストランツな。はいはいはい。
material. So let
で、これカラー取ってこなきゃダメなのか。
me set up material. Here you can see we drop a
2つあるぞ。なんでだ。
particle attribute lookup, arrest point attribute node, attribute name is CD what's there, so I up the roughness and CD what's there, so I up the roughness and that's it, plugged into the redshift material. And this one is for the backplate. We also here we have a back
同じ場所に作っちゃっていいんだっけ。
plate. Then we add this redshift material here in the line wave render tab. Redshift object. Add this redshift.
そうか。そのマテリアルビルドは使わなくても、この組み合わせ作りゃいいのか。なるほど。
Backplate. We also, here we have a backplate. Then we add this redshift material here in the line wave render tab. Redshift obj.
小さすぎか。
We click to the tabs called strands and we check the render objects as strands. Strand type should be cylinder, default scale should be 1, and global scale multiplier, it really depends on the number of your splines. So in my case, for 2000 splines, I needed global scale multiplier set to 0.004. Then you also will need a camera, which you can create by clicking here, new camera, and yeah, that's basically it. Here will be your redshift camera, all cool and easy. So let's fire up render view. Now here you can see that
タブはいじったことねえな。エクスポーズとコンストラストを上げれる。
by clicking here, new camera, and yeah, that's basically it. Here will be your redshift camera, all cool and easy. So let's fire up render view. Now here you can see that everything's working, all good. Maybe let's readjust the camera to something like this. And now
デフォルトをなんか適当に使う。
let's up the count. For example, we want, I don't know, let's say 1000, just because it will be easier for us to see. And yep, here we have it. Here I have two redshift lights. Let me show you. Yeah, basically one is from this side and the second one is located somewhere here. And I also have an HDRI here. So yeah, I think that's it for today, guys. Thanks a lot for watching, and I think that's it for today, guys. Thanks a lot for watching, and I really hope this tutorial was useful. If it was, don't forget to leave this video a like, and don't forget that all of my tutorials have project files available for you to download. It's the best way how you can support me in my path of creating these tutorials for you. So
うん。こんなもんか。うん。あとはなんか、ちょっといじるか。と、一旦動画は全部終わりました。まあなんか動画のタイプによっては、まあなんかこんな感じで、なんだろう、一から作っていくっていうよりは、こう、一個一個、最初からあるやつを一個一個説明していくみたいなやつもあるので、まあ、こういうタイプだと、ちょっと、英語をちゃんと聞き取らないと変更点が分かんなかったりとかして、若干手間取ったりするんですよね。もう今日は、こんな感じで、こんな感じのやつを、まあ、マスクかけて変化の場所を変えるみたいな感じですね。意外と中のノードの組み方自体はシンプルでしたね。このベンドの使い方が、ベンドはなんかいまいちまだちゃんと使えてないノードの一つでもあるんで、なんかこの辺のチェックを外さなきゃいけないとか。まあ多分このプリミティブをまあ LINE で作ってある。プリミティブの線で Q を作ってあげればいいので、まあ、別にベンドを使わずとも、まあ、例えば普通に、でもあれじゃできないのか。ベックス書いて、サインかコサインで半円にしてあげるっていうのでもいいのかなって気はしますね。逆にこの辺なんでマイナス0.1なんだとか、まあ多分このサークルが0.1だから、まあ、そこのスケールに合わせて、間が0.1履くように インスタンティーとなるようにってやってるんだと思うんですが、まあ、なんでこの辺でよくわからんってなるよりは、普通にベックスで半円書いちゃった方が、もしかすると人によってはやりやすいのかもしれないです。あとはまあここのディスタンスフロムジオメトリーで、まあ、距離に応じてマスクのアトリビュート作ってあげて、それをラープでポイントをブレンドするみたいな感じのがポイントですかね。割とやってることは結構シンプルでしたが、まあ、なんかいろいろこの辺のマスクフロムジオメトリーのアニメーションもさせる部分とかは、まあ結構いろんなことに応用が効きそうな使い方だったので、まあ、すぐ他の形状にも応用しやすそうだな。まあ、プリミティブでラインを、まあなんか目的のオブジェクトをラインプリミティブで生成、コンバートしてあげてみたいな感じですかね。どうなんだろう、そんなさっくりできんのかな。いつも通り顔でやってみよう。で、コンバートラインかますだけで、これで何プリミティブぐらいあるんだ。結構な数あるよ。うん、としてポイントとして、してんだ。本線を作るってなると、これは。これでアトリビュートアップして、まあ、ぐちゃぐちゃになるっちゃなるから、強引にこのセットアップでもいけなくはない気がするな。0.1。サイズか。マッチサイズ。レングスは確か10あったから10か。でかすぎるか。こんなもんか。じゃあ試しにやってみよう。 スがプリミティブ。直さないと無理かな。すぐにはできなそうだな。単純ではなさそうだな。ポイントがあって、ちょっとトーラスがいて、ここにいて、上がっていく。このタイミングで、マスクの値は入ってるけど、全く通ってないよね。トーラスは形状的に適さねえな。変えよう。うん、これってマージされてないからラインは死んでんのか。いや、出てんのか。出てるか。うん。なるほど。こんな感じか。はい。まあ、なんで、一応、ラインとプリミティブで作れれば、他の形状にも割と応用しやすそうな感じなので、ちょっと適当にレンダリングしてみようと思います。はい、では今日の配信を終わります。ご視聴ありがとうございました。